I am on a mission to make the world's most hackable mechanical keyboard. My first try was full of dumb ideas done well. The second was great ideas done stupid. Today, we're going to nail the bullseye, we're going to thread the needle, we are going to appropriate a fictional concept from the mechanical keyboard community and enter the endgame. Today, we build the MiRage Mk3. Ladies, gentlemen, and cyborgs, welcome to Voidstar Lab, where it takes so much work to make a single video. It took 9 months to scrape together enough spare hours to make the MiRage Mk2. Yet here we are, barely 6 weeks later, and I didn't just make its successor, I made 3 versions of it, and accessories, and a chassis. And it's all because today's sponsor originally wanted a 3D printing episode, but asked if we could switch to circuits. This episode is sponsored by a product that does both, and it's one you might have heard of. Fusion 360 by Autodesk. Joke's on them, I was going to use it anyways. If you've seen the Parts Rainbow, my Quagsire, the MiRage Mk1, the Chromance, the Data Blaster, or really anything I've built on this channel, you've seen me use Fusion 360. It's really the perfect CAD for prototyping because it lets you roll back the clock and retroactively fix mistakes. But I've never used Fusion for electronics. Technically. When I started this video, I was still using Eagle 7. Autodesk bought Eagle like 6 years ago and they just did it right into Fusion. You just hit File, New Electronics Project, and there you go. No downloads, no upcharge. The real electronics design assistance was inside you the whole time. Since 2014, they've added stuff like self-enforcing DRC, multi-track routing, cam previews, and just tons of UI improvements that carved hours off the Mk3. I'll admit, I also underestimated the power of being able to design a 3D model around the circuit board itself. If you've never used Fusion 360 before, you totally should, and if you've only used it for 3D printing, you should check out the electronics. Click the link in the description for a free trial to accelerate your next project. So how did I wield this newfound power? For a start, fixing the many mistakes we ran into with the Mk2. The headline feature last time was the RGB LEDs, and I learned the hard way that even these tiny 2mm ones could block many popular key switches. But I wasn't expecting a lot of the comments that pointed out that these teeny-weeny LEDs look just downright terrifying to solder. I don't think they're that hard, but I've been doing this for a while, and my main priority is to make hacking the MiRage as practical as possible. Hackticality is about more than just compatibility with more parts, it's about accessibility so more people can make their dream keyboard. I know you got a dream keyboard. So I swapped out the surface mount RGBLEDs for reverse mount RGBLEDs. These use a different chip, but are drop-in compatible, as in you literally drop them into a cutout on the board so the lens sits flush with the other side. It's a sneaky way to infuse any switch with pro gamer goodness without increasing the profile of the board at all. It doesn't matter if the switch is designed for through-hole, surface mount, or no LEDs whatsoever, this will work fine on all of them. I mean, it won't help if your switch is black, but you know, just get some clear paint. On top of that, these pins are much larger than the tiny surface mount pads and are just a pleasure to solder. It's a pleasure, it's pleasurable. But I made a boo-boo. NeoPixel style RGBLEDs are 5-volt devices, and we're using the Seed Studio Zhao RP2040, a 3.3 volt microcontroller. It theoretically shouldn't be able to control these LEDs, but the difference between theory and practice is greater in practice than in theory. In practice, the old surface mount RGBLEDs work just fine, but the reverse mount ones did not. So I had to hack in a level shifter. The MiRage can be configured as either a monolithic plank or a split keyboard, and for the latter, you have to electrically link the halves. For the Mk1, the right side's microcontroller powered and communicated with the left side's I/O expanders over a TRRS headphone cable. But the Mk2 added RGBLEDs and interrupt pins, so we needed 7 wires instead of 4. Enter my brilliant solution, the SATA port. It's got 7 pins, it's got fancy cables, it seems fine, except it turns out a SATA cable only has 5 wires, and now this worthless tape of regret will clutter my workshop forevermore. There really is no alternative to the 3.5mm cable for keyboards. We can't go USB because the Xiao doesn't break out the USB data lines. We can't use modular cables either, like Ethernet, because they're ugly. And don't give me that personal preference horseshit. A single standardized set of aesthetic preferences was hard-coded into every human's DNA when we were still lobsters. Read a book. So Zack cracked and tacked the Jack hack back. To make it happen, the MiRage needed a monumental architectural change. And while I psyched myself up for that, I put the board on a diet. The Mark II's footprint was way too huge, like nearly the size of a full-size keyboard, despite only having the keys of 65%. I turned the jacks 90 degrees to shorten the board, and note how the left port is slightly inset. This relief lets you butt boards up edge to edge, so if you ever want to switch back from a split to plane configuration, you don't have to desolder anything. Despite the galactic intellect on display here, I forgot I had to add a cutout for the plug too. I'm still amazed nobody called me out last video for selecting the biggest, stupidest possible package for the I/O expanders. This time I swapped them for the much more sensible TSSOP package, making the board even shorter and tossing another coil of shame on my pile of parts to use someday. The single most requested feature on this project has been magnetic pogo pin connectors. So Merry Christmas, you filthy animals. The MiRage is not a wireless board, so you can't just like cleave the board in twain and keep typing. Either way, these are optional, and you can just bridge the SMD pads with solder if you don't understand how magnets work. The flashiest addition is what's missing, he said not ironically but oxymoronically. The Mark I had OLED display buttons, but they were more crackable than clickable. The Mark II got an e-ink touchscreen, but it was both awkwardly thin and way too wide. Onboard displays have always been the MiRage's most distinct feature, and while cutting them is the objectively correct decision, it was a hard pill to swallow. So I spat that pill on the ground and I made a display module. That's right, LGs and Cs, these are not just hotswap macro keys, they're also hotswap module sockets. The display module packs the same 2.7-inch e-paper touchscreen that I used last time, but the stacking headers raise it to a comfortable height, and because it can now hang off the edge of the board, you can detach it if you want a smaller footprint. I took the opportunity to add an RGB LED backlight, a linear resonance actuator, and a haptic driver for realistic clicky feedback. At least this is where the haptic driver would be if DigiKey had one. I actually made 3 modules, and the other 2 were selected by a survey in the MiRage newsletter. If you want to keep up with the project and see the nitty-gritty inside baseball stuff that I can't make an interesting video about, sign up in the pinned comment. Keyboard spam only, I pinky promise. I'm going to sandbag those last 2 modules to increase my retention metrics. Now remember, we want to string together an infinite number of standalone keyboard halves, each with their own backlights, I/O expanders, and now modules, and we only have a 4-wire cable to do it. Last time we discovered this little bastard actually has 2 I2C interfaces, so if we configure its last 2 pins as an I2C peripheral, and if we're okay with putting a separate microcontroller into each half, each board's neighbor can read it like a fiddle. But I was not okay with that. Since day one, I've had an ironclad, uncompromising, and increasingly irrational fixation with putting exactly 1 microcontroller in every MiRage, no exceptions. The time had come to face my demons. So I procured a bulging bag of a notoriously potent plant that's legal in Colorado, I ingested a heroic dose, and I lapsed into a trance-like state. I'm not talking about the jazz cabbage, I'm talking about hatch chilies. I lost myself in a smothered burrito-induced capsaicin hallucination to confront the trauma I had repressed of configuring, compiling, and deploying multiple instances of QMK onto my Infinity Ergodox's multiple processors. That's why I could never use multiple microcontrollers. This cycle of abuse must be broken. But suddenly, the burrito part of the smothered burrito took effect, and I realized that my fears too were nothing but hot, noisy air. The MiRage was never going to run QMK, it was going to run VoLTAIK, the Voidstar Lab totally adaptable interface for keyboards, and I've been designing that specifically so you never have to recompile firmware after you change your key maps. That's my new name for the MiRage firmware, and I'm still porting it from CircuitPython to C++, so there's nothing to announce except the name, but come on, it's a really cool name. Tell me how cool VoLTAIK firmware's name is in the comment section below the like button. So now each half gets its own independent Zhao RP2040. Seed Studios' influencer marketing team must be flogging that simultaneous flossing and pogging. I fired up Fusion's vastly improved CAM processor, generated Gerber files, shipped them off to an unsustainably cheap overseas fab house, and then made a very uncharacteristic move: getting other people's opinions. I sent out a survey to the over 7,000 people who signed up for the MiRage newsletter, and the results revealed that I had made a huge mistake. The survey's primary goal was to figure out which modules to build first, so I loaded it with spicy ideas like Bluetooth, a breathalyzer, Nixie tubes, and a TrackPoint style mousing device. But the overwhelming winners were macro keys, encoder knobs, and sliders. These were suspiciously normal. Still, the people had spoken. You already get macro keys for free, so I now had my next two mods to make. First, the knob mod. I can't really read the MiRage's I/O expanders fast enough to capture quadrature encoder signal pulses. But now that I had overcome my fear of redundant microcontrollers, I just plopped an Atmega on there. Dedicated quadrature decoders exist, but they actually cost more than the Arduino, and this replaces the EEPROM. Every MiRage module is getting an onboard memory chip, so it can identify itself and store settings on the module itself. I immediately ran into a problem. The module sockets blocked clickable and RGBLED encoders pins. But throughout this journey, I had made more than just mistakes and bad keyboards. I made friends. There's no point having friends if you don't sponge them for free shit. MK Ultra Keyboards bailed me out with a massive care package bulging with esoteric key switches, fancy space-themed keycaps, a rainbow of their signature razor-thin Choc dealios, and their brand new oversized mouse mats. This one is perfect for the wannabe Dana Scully.
That's me!
I normally don't do shoutouts in return for products, but when I opened this bag of buttery smooth Momoka Frog key switches, something sprayed in my face and now my lips are moving on their own. But the important part was in these silicone jars, and it wasn't dank dabs, it was rare low-profile encoders and custom anodized knobs for them. These don't just have shorter shafts, they have hollow shafts. And who really needs a haircut and has a bag of LEDs that sit flush with a circuit board? This guy. I'm aware the knobs block the RGBLEDs. I made 2 encoder modules, you jabroni. The second most requested module was sliders, and I went a smidgen too far. Big surprise, I know. I gave each one a row of RGBLEDs. I added another coprocessor to read them. The RP2040 doesn't have great analog. And I topped it off with an optional OLED. Welcome to Voidstar Lab, where our modules get modules. Sliders impose some interesting requirements on the firmware since they stay in one of many states instead of being either temporarily pressed or not. It's good to have all this information now as I structure the VoLTAIK project. So I ordered even more circuit boards, and I went back to the survey data because something was really chapping my cheeks. Here's the situation. Early in the project, I chose to orient the key switches so the LED is at the 12 o'clock position. This is called north-facing switches, and it's standard for most keyboards, especially ones with LEDs. If you install shine-through keycaps with translucent legends, this will usually place the light directly beneath the letter for maximum retinal stimulation. There's really only one reason to use south-facing switches: cherry profile keycaps. As bizarre as this sounds, the Cherry company that invented the MX switch originally intended them to be installed upside down, and their first-party keycap design will collide with the housing if the switch is installed logo side up. Cherry profile caps are kind of old school. They've been almost entirely supplanted by the similar OEM profile. Almost entirely. GMK keycaps are a status symbol among keyboard cognoscenti, and they're still made in the Cherry profile for that old school look. The people who buy them tend to think shine-through caps are lowbrow garbage, and they only will buy a keyboard if it has south-facing LEDs. I didn't really think they were the target market though. Like, I've never mentioned this board on any subreddit, forum, or Discord, or just any place else you'd find keyboard enthusiasts, because I figure the MiRage is low-profile, goofy displays, I/O expanders, lack of thought, and pretty much everything else would get me flamed to hell and shown the door. The type of dabblers who watch my channel generally are not the type who'd spend $215 for the privilege of waiting 47 weeks for a set of keycaps that looks like something an 80s business guy would hoover a schneef off of. North-facing was the clear choice, or the translucent choice, am I right? The modules people wanted seem to have the same features as some recently hyped keyboards in the mechanical keyboard community. On top of that, 15% of respondents weren't planning to use the RGB LEDs at all, and a third would cut them to shave $20 off the cost. Other questions about the ortholinear layout and opinions on 3D printed parts revealed that there were way more serious keyboard nerds in the audience than I expected. The scales were tipped literally in the wrong direction. If I didn't rip up this brand new board, spin those switches around, and redo it, people were not going to buy the keyboard. I shipped the Gerbers back to the unspecified overseas fab house, and why not get the solder stencil? With the right side locked down, I started on the left. They might look like mirror images, but they're not. The left headphone jack still needs to be inset. This pushes the Xiao microcontroller right up to the upper right key switch. The module sockets also aren't mirrored, and that made this much more of a challenge to route. It took me a few days to do the left side, but routing 6 boards in 6 weeks had left me pooped, and in my vulnerable state, I allowed myself to get sidetracked making PCB art. Not only did I place my order too late, turns out when you pay a fab house $25, they're less willing to put up with dozens of sharp edge cutouts, 100 overlapping drill hits, multiple megabytes of silkscreen, and a poorly worded rush request. So the board got delayed a week, and I could not get it done in time for this episode. But remember, both boards now have independent microcontrollers, so we don't actually need the left side to make it a complete keyboard. You could say that in its current state, the MiRage is alright. My solder stencil turned out to be a tiny bit bigger than expected. I think I might have specified a 100mm border instead of a 10mm border. But the Mark III turned out to be much easier to assemble than its predecessors, even with a capacitor on every LED. The I/O expanders are easy to solder. You just throw a blob down and drag it across. And the rest of the parts have these big fat pads that make it really easy to solder this thing quickly. This is going to be a great first soldering project for, you. The Mark II had so many problems I didn't bother making an enclosure for it, but this time I had no excuse. I uncorked my prototyping scotch, imported both boards into Fusion's 3D workspace, and proceeded to grind out the absolute sloppiest model of my entire career. This enclosure is so f***ed, it doesn't know how f***ed it is. Everything breaks when I recalculate the design. At some point, I passed some sort of badness event horizon because every attempt at fixing anything just ruined more and more. I had to go back in time with the versioning system just to salvage something I could print. But it all got done. The tray has tons of mounting bosses to handle left or right boards as well as their modules. The support plate mounts to both the board and tray to improve the stability of the 3D printed parts. And this detachable mini plate lets you clear the way for modules. We got boards, we got modules, we got enclosures, we got everything we need to build some gosh darned mother-hugging keyboards. So to sum it up, the MiRage is moving forward way faster and way better than I expected, and by the time you watch this, my radical viewers of the near future, the left half should have arrived, and I'll be hard at work, throwing some parts on that, refactoring the enclosure, and rearranging the modules. I forgot to mention before, but when I turned the switches around, that shifted the sockets for the modules up a little bit, and now they don't line up. Wasn't worth fixing for this episode, but I don't know. Perhaps if you join our newsletter, you'll see everything fit together nicely. Of course, thanks to the Fusion 360 team for supporting Voidstar Lab, as well as writing a really good CAD suite for rapid hardware development. More info in the description. But do you know what's better than hammering kale box jades until your coworkers cold cock you with a fire extinguisher? Our patrons. Folks like lab scientists, Redwinds, Techers, and Teflon cover our preposterous development costs and let me give away everything we design as free open source. The majestic beacons of generosity we call collaborators include Command, Creality Online Store, Karen Houseman, Castor the Catboy, and introducing Schleppy the Schwagster. Hey there, Zack from the future here. My favorite part of shooting these videos is stifling my snort laughter as I try to read your spicy usernames, but this time the spice was too spicy. The sponsor's legal team refused to sign off on the video, and we've been going back and forth for over 2 weeks as I fought for your right to call yourself a I don't want to have to shill predatory games and scamtastic crypto to make ends meet, and that means the occasional hard decision to keep good partners. This time I chose to preserve a relationship with a company that serves the maker world and whose products I personally use. In the future, I'll ensure that sponsors understand that the spice must flow, and if their lawyers are less lenient of last dab level labels, leave my loony legion loads of leeway to lay down a line less loaded with legal liability. I have made a very special cut for my patrons to view that doesn't have any of the sponsors' branding, and I promise to thank all the missing supporters in my next video, even those who understandably pull their support. That video features one of the most important projects I'll ever build, but no spoilers. Thanks for your support, thanks for watching, and enjoy some mechanical keyboard ASMR.